I want you to start by picturing a very specific, very stressful scenario.
Okay.
You're in the cockpit of this massive machine. It weighs tons. It's loud. And you're staring down at a runway that, let's say, really stretches the definition of the word runway.
So not exactly JFK International.
Definitely not. Maybe it's packed dirt, maybe gravel, or concrete that's been bombed out and patched up.
Got it.
But here's where the stress really kicks in. Let's look at your travel itinerary. Yesterday, you were operating in the absolute zero deep freeze of Antarctica.
Brutal conditions.
Yeah.
Metal contracting, fluids thickening.
Exactly. But today, you're navigating the humid, sticky, suffocating heat of the Amazon basin.
And just to round it out, tomorrow you're probably dealing with fine grit and sandstorms in a desert.
That's it. Now, in the world of engineering, that kind of environmental whiplash is usually a disaster waiting to happen.
Oh, absolutely. It's an engineering nightmare.
Most machines are built for one thing, one environment. You ask a single machine to handle all that, things start to break.
Seals fail, electronics short out, engines complain. You usually have a plane designed for the cold or one fitted for the desert. You don't often find one that claims to be comfortable in both without a massive overhaul.
And yet the aircraft we're talking about today claims it can handle all of that without blinking. But it's not just the weather, it's the job.
Right.
One flight, you're a cargo truck.
Right.
The next, a flying hospital. The next, a paratrooper launch pad. Then a refueler.
It sounds like we're describing the inventory of an entire Air Force, not one plane.
But we aren't. We're talking about one single airframe. Today we're doing a deep dive into the Embraer KC-390 Millennium.
Okay.
And our mission for this deep dive is to figure out if this thing can actually live up to that claim of being a truly multi-mission platform. Because we've seen this before, right?
Oh, yeah. The jack of all trades, master of none syndrome. It's a huge risk. You try to build a plane that does everything, and you end up with one that's too heavy, too small, or just too expensive to fly.
So, looking at the technical specs we have here, does the KC-390 actually pull this off? Is it really the Swiss Army knife of the skies?
It is a bold claim, no doubt,
Right.
but it makes sense why they built it this way. We're moving away from having a massive specialized fleet,
Because it's too expensive.
incredibly expensive, and a logistical nightmare. The trend now is unrivaled mobility, flexibility. Air Forces want one asset that can wake up and decide what it needs to be that day.
Okay, so let's put that flexibility to the test. I want to know what unrivaled mobility actually looks like. When you open the ramp of this plane, what can you actually fit in there?
Well, the cargo compartment is really the heart of the argument. It's not just an empty tube, it's a reconfigurable space.
Modular.
Very modular. So if you're running a true transport mission, it's not just guys on the floor. It configures to carry up to 80 soldiers.
80? I mean, that's a significant number. That's basically a full company of soldiers in one lift.
It is. But say the mission changes. You need to drop them into a combat zone. You can reconfigure the interior for paratroopers. It can hold 64 fully equipped paratroopers.
And that's very different from 80 regular passengers, right?
Well, a huge difference. Paratroopers are bulky. You have the main chute, the reserve, weapon, rucksack. It's a high-volume loadout. Fitting 64 of them in and still giving them room to move is a design challenge in itself.
Okay, but here's the configuration that actually surprised me. The medevac, medical evacuation.
Right.
I think people assume you just put a stretcher on the floor of a cargo plane and hope for the best. But this is way more sophisticated.
It's makeshift. No.
Yeah.
The KC-390 can be rigged for up to 80 litters. That's 80 stretchers.
Wow.
Or, and this is that flexibility, a mix. You can do 36 ambulatory passengers wounded, but can walk, plus 50 litters. But the key part is the staff. You could have 74 litters with 8 medical attendants.
So it's not just an ambulance, it's a flying ward. You have doctors and nurses working on patients in the air.
Precisely. Think about disaster relief, earthquakes, floods. That capability is vital. You're stabilizing patients immediately, turning the aircraft into a critical care unit the moment the wheels leave the ground.
Now, we have to talk about the heavy stuff. Vehicles. Because usually for heavy armor, you need a massive airlifter, like a C-17. But this is a medium airlifter.
It really punches above its weight class here. It can handle 3 to 4 light vehicles, think Humvees, or it can take 1 or 2 heavy armored vehicles. But there's one payload that really turns heads.
I think I know what you're about to say. The helicopter.
I am. The KC-390 can carry a Black Hawk H-60, or a similar-sized helicopter, inside its cargo hold.
Okay, I need to pause on that. A Black Hawk is not a small machine. How do you just roll a helicopter into the back of a plane.
Well, you do have to prep it, fold the rotors, secure the tail.
Yeah.
But you don't have to completely disassemble it into a crate of parts.
And that's a massive difference.
It's a game changer. Flying a Black Hawk somewhere takes forever. It's slow, it burns a ton of fuel.
Plus all the wear and tear just getting it to the fight.
Exactly. And if you have to take it apart completely, you need a whole engineering team to rebuild it. With KC-390, you just roll it out, unfold the blades, run your checks, and it's operational.
So the KC-390 is kind of a mothership.
Essentially, yes. That's what we mean by interoperability. You're using the speed of the jet to deploy the versatility of the helicopter.
Okay, so I can see why the life cycle cost argument comes up.
It's the boring part of defense, but it's the most important. If you could do all those jobs with one airframe, you need one supply chain, one flight simulator, one type of mechanic. The savings are astronomical.
Right. So we've established it's a beast in the back, but let's move to the front. The cockpit. Because it doesn't matter what you're carrying if the pilot can't handle the plane.
And this is where the KC-390 really separates itself from, say, an older C-130. Those older planes are very mechanical, a lot of wrestling with analog dials. The KC-390 is a digital native.
The documentation mentions the Rockwell-Collins Pro-Line Fusion Suite. What does that actually mean?
It means data fusion. In an old cockpit, you have a dial for speed, a dial for altitude, a separate screen for radar.
You're trying to watch 9 different TV channels at once.
Exactly. And you have to build a picture in your head. The Pro-Line Fusion Suite takes all that data, processes it, and puts it on large touch screens. It shows you the situation, not just the raw numbers.
So it reduces the mental math the pilot has to do.
It reduces the cognitive load. That's the term. If you're flying into a combat zone in bad weather, you want the plane to tell you, here's the threat, here's the runway, all in one clear visual.
And that plays into the fly-by-wire system, doesn't it? What's the practical benefit of that?
So in a traditional plane, the stick is connected to cables that physically pull the flaps. It's heavy work.
Right.
And you can physically force the plane into a bad situation, like stalling it. Fly-by-wire means the stick sends a signal to a computer. The computer analyzes it, then moves the flaps.
So the computer is a middleman.
A chaperone. It's designed to let the pilot fly to the limits of the flight envelope. If you need to bank hard to avoid a missile, you can slam the stick over, and the computer gives you the max possible turn without ripping the wings off.
It protects the pilot from themselves.
It allows for carefree handling. You can focus on the mission, not on whether you're about to stall the aircraft.
That seems incredibly valuable. But what about when you can't see? We have this alphabet soup of acronyms. HUD, EVS, SES.
HUD is the head-up display. That's the glass pane that projects data so you don't have to look down.
Okay.
But the magic is in EVS and SVS. SVS is synthetic vision system.
Like a video game.
Very similar. It's based on real-world mapping data. If you're flying into a valley in thick fog, your eyes just see gray. SVS paints the mountains and the runway on your screen in 3D.
So you're flying in the Matrix, basically.
Essentially, yeah. And EVS, enhanced vision, uses infrared cameras to pierce through darkness or smoke and overlays that real thermal image. You combine them, and the pilot has near-perfect awareness no matter the weather.
And on top of that, there's the spot SAR, the radar.
Right. Spotlight Synthetic Aperture Radar. It's a tactical radar. It can map the ground in high resolution, identify targets, even track other aircraft.
And the whole plane is NVIS compatible.
Night vision imaging system. That's critical. You can't just wear night vision goggles in a normal cockpit. The dashboard lights would blind you. The KC-390's lighting is tuned to work perfectly with the goggles.
Okay, so we've covered the brawn and the brains, but I want to talk about how the cargo actually leaves the plane. The chassis system.
The cargo handling and aerial delivery system.
It sounds like a character from a movie, but it's this sophisticated rail system. The interesting part for me is the loadmaster. In the movies, that's the guy hanging out the back, yelling over the wind.
That's the old school way, and it's dangerous. In the KC-390, the loadmaster has a dedicated station.
And it has ballistic protection.
Right. They're in an armored booth, looking at screens that monitor all the locks and the weight distribution. They operate the CHA's system digitally. They're a systems operator, not a manual laborer.
And that system includes something called the CCDP, the Continuous Computed Drop Point. This felt like magic.
It solves one of the hardest problems, gravity and wind. If you're flying at 300 knots, the window to release a pallet is tiny. 1 second too late, and it lands miles away.
And that used to be a navigator with a stopwatch, right?
Yes, and it was prone to error. The CCDP uses the plane's speed, altitude, wind data, all of it. to calculate the exact release point, and it's continuous, so it's constantly updating.
Does it drop the cargo automatically?
It can. It calculates the point and can trigger the release. It takes the guesswork out and makes sure supplies actually reach the people who need them.
There was one other mechanical detail I wanted to hit on, the hydraulic strut stabilizer.
Ah, yes, a great little feature. When you're loading a heavy vehicle, the plane's suspension bounces and tilts.
Which is slow and dangerous, and time on the ground is bad.
Time on the ground is vulnerability. A stationary plane is a target. The stabilizer locks the landing gear, makes the plane a rigid platform, no bounce.
So you can drive a tank on, lock it, and get out fast.
Minimize vulnerability, that's the goal. Get in, load, and get out.
Which is a perfect segue to survivability, because no matter how fast you load, you're still flying a big target into dangerous places. How does a transport plane defend itself?
Well, it can't dogfight, so the strategy is detection and avoidance. It starts with knowing you're being watched. It has radar and laser warning systems.
So if a missile battery paints the plane with radar, an alarm goes off.
Immediately.
Yeah.
It also has a missile approach warning system. If a missile is actually launched, it detects the rocket motor's heat signature.
And then what? It can't outrun it.
It uses countermeasures. The classics are chaff and flares. Chaff confuses radar, flares distract heat-seeking missiles, but it also has DIRCM.
Directional infrared countermeasures.
This is the high-tech stuff. Instead of just dropping a flare and hoping, DIRCM uses a turret to fire a beam of energy, usually a laser, directly into the missile's seeker head.
It shoots a laser at the missile's eye.
Basically, it blinds the missile's guidance system. It's a very sophisticated way to stop those shoulder-fired missiles that are a huge threat.
If a hit does get through.
Then you rely on armor and system, a system called OBIGGS, Onboard Inert Gas Generating System.
That is a mouthful.
It prevents the fuel tanks from exploding. See, a half-empty fuel tank is full of explosive fuel vapors. OBGGS pumps nitrogen into the tanks to displace the oxygen.
So it creates an atmosphere inside the tank that literally can't burn.
Exactly. It reduces flammability, turns the fuel tank from a potential bomb into just a container of liquid. It's a huge survivability factor.
It's impressive. But there's one final area, the unsung hero section, maintenance and economics.
This is where people usually tune out, but for an Air Force general, this is the most exciting part.
Right. A broken plane is an expensive paperweight. The source talks about life cycle costs and the OMS onboard maintenance system.
The OMS is the plane diagnosing itself. It's constantly monitoring its own health.
Like a Fitbit for the airplane.
A very advanced Fitbit, yeah. If a valve is sticking, the OMS records it and alerts the crew. It tells them what's wrong.
So instead of mechanics spending hours trying to figure out why a light is blinking, the plane just tells them, replace part X.
Precisely. And that's a game changer for turnaround time. The mechanic can be waiting on the runway with the part in hand.
And that ties into the MSD3 methodology they mentioned.
Yes, that's an airline standard. It means the maintenance program was designed from the start to be efficient. They built it to be fixed.
And why is that so important for the military?
Because of a metric called availability. You can have the best plane in the world, but if it needs 20 hours of maintenance for every 1 hour of flight, it's useless. This plane is designed to be ready to fly when the mission comes down.
It seems like the recurring theme here is that this isn't just a brute force machine, it's a smart machine.
That is the perfect summary. It's a generational shift from dumb iron, just engines and metal, to smart platforms. The KC-390 uses algorithms for airdrops, lasers for defense, data fusion for piloting.
It really is the Swiss Army knife. It's not just that it has a knife and a corkscrew. It's that the hinge doesn't break and it tells you when it needs oil.
And it knows exactly how to use itself to get the job done.
So let's wrap this up. We have a plane that can land on dirt, swallow a helicopter, sees through fog, fights off missiles with lasers, and emails the mechanic what's broken before it even lands.
It's a comprehensive platform for sure. It's a very convincing argument for the future of medium airlift.
It is incredible engineering. But I want to leave you and our listeners with a thought. We talked about the algorithm deciding the drop point, the computer preventing a stall, the plane diagnosing its own repairs.
I see where you're going. The machine is taking over the expertise.
Exactly. As these machines get smarter and the software takes over these critical calculations, how much of the skill is migrating from the human to the code? Are we looking at a future where the pilot is less of an aviator and more of a systems manager?
That's the million-dollar question in aerospace. Right now, the KC-390 proves man and machine work better together. But the machine is definitely doing the heavy lifting on the math. It allows the human to focus on tactics, not the mechanics of flying. But yes, The role of the pilot is fundamentally changing.
Something to chew on the next time you see a transport plane humming overhead. It might be doing a lot more thinking than you realize. Thanks for diving deep with us.
Always a pleasure.
Stay curious, everyone. We'll catch you on the next deep dive.